Hi everyone, my name is Lydia, and this is what I wish they taught me about econometrics and introduction. In the previous video, when we saw the output regression for stata, there was a particular block with a few new elements, and we didn't stop to look at each of these elements separately because that would have taken too much time. So in this video, we're going to concentrate exactly on these three elements in here. The sum of squares, for which we have the total sum of square, residual sum of square, and model sum of squares. Today, in this particular video, you'll understand what they mean conceptually. We're not going to touch any formulas, but remember that as long as you understand the intuition behind it, it's going to make learning the formulas and using them a lot more easier for you as well. Let's start from the simplest idea, variation in y. So we have a dependent variable y, and when we're talking about the variation of y, we want to measure how much this y varies from the most natural benchmark that is normally used, the mean. Okay? So as variation is always measured relative to something, for all of these sum of squares variables that we're going to have here, the variation from the mean is going to be a key concept or element. So if we start from the first one, the total sum of squares is going to measure how far observations are of y are from the mean, which we'll call like the y bar. Okay, so keep in mind this TSS is giving us the variation in y before you use any model. So this is based on the data that you have on y. So basically on all the observations that you have in that particular data set for the y, you can literally compute it separately without you having to run a regression to get that number. Now, if we bring in the regression line usually is going to give you the fitted values. So if your model was y equal to some beta null, beta 1x1, beta 2x2, and beta 3x3, as it was in our case, the moment that we are estimating it, we're getting y hat equals to beta null hat, beta 1 hat x1, plus beta 2 hat x2, and then beta 3 hat x3. And this y is your fitted value or your predicted value based on the model that you have just created in here. Which brings us to the explained. So explained sum of squares, which is going to tell you how much of the variation in y is explained by the regression. So it's literally saying how far the fitted values are from the mean of y. How far? So that's y bar. In a sense, the ESS is the variation that the model explains. That's why we're using explained as like the actual acronym for ESS. And ultimately, we've got the residual sum of squares. Because when we move from the theoretical model to the estimated model, then we can calculate the residual, which is the difference from your real observation to what your prediction is. So what then does the residual sum of squares do? Well, it's going to measure how far actual y values are from the theta values. Okay? So this is the variation left unexplained by the model. It's encapsulated into that residual. So the RSS, in a sense, is the variation that the model fails to explain. So from here, there is like the big identity that can be used. So these three quantities are linked together by a simple idea, simple formula. And that is, well, the total variation should be the explained plus the unexplained variation. So total sum of squares should be equal to the explained sum of squares plus the residual sum of squares. So it should be quite intuitive. Now, keep in mind, this decomposition, in fact, is not just cosmetic, okay? It's at the backbone of anything that has to do with the R squared, with the F test, and model comparisons, okay? So it means that any kind of diagnostic test or any interpretations that we're going to do next is going to rest on this idea or like this big identity that you have in here. Okay. If you understand conceptually what the total sum of squares is and the two components, estimated sum of squares and the residual sum of squares conceptually, the math which will follow in the next video will feel a lot more natural and not as if you're doing some sort of econometric magic. Okay? I hope this was helpful, and I'll see you in the next video.